Evil twin attack is an interesting variant of client attack. The attack targets business VLAN clients. Attackers have to set up an access point with an SSID that is expected from a user. The rogue access point has to emit a signal that's greater in strength than the legitimate access points. A user knows that enterprise networks are protected and that he'll have to log in to connect. That's why a rogue access point will also employ a logging mechanism. A Radius server verifies user credentials in business networks. Our access point will also be a Radius server client, but unlike a legitimate Radius server, the evil server will authenticate all users regardless of submitted logins and passwords. This means that users will always connect to our access points. Whether or not they will be granted internet access depends on our access point configurations and our subsequent agenda. Until we physically connect our access point to a business network, users will not be able to access the network. The damage, however, is already done. A user sent his credentials to an attacker freely. He had to do it because a Radius server client, the access point, had to send it to the server. The data will either be sent in clear text or as a challenge and response message depending on a Radius configuration. If the PAP protocol was used, the data will be transmitted in clear text. Because an attacker is not trying to make his own life more difficult, he'll set his rogue access point and Radius server to use PAP. Radius clients negotiate different authentication levels from a list configured by an administrator. If a user agrees to use PAP, it's very simple from then on. If he doesn't, and goes on to negotiate a higher level authentication protocol, for example MS-CHAP, the challenge and response message will be encrypted with the user password. The encryption will have to be reversed. This operation will take us about 15 seconds. At this point, an attacker has obtained the user credentials. If he manages to physically connect to an enterprise network, he can, for example, log in as the victim. The fact that a user is connected to an access point means that the attacker is fully able to control a client. In this scenario, we did not expect any need for major user activity. A client was only expected to connect to an access point. What are the countermeasures? As a rule, you shouldn't only prove your identity to an access point. The access point should also prove its identity to you by way of mutual authentication. This would help prevent impersonating a trusted access point. Mutual authentication can easily be configured in Windows systems locally, or using group rules. You can see the latter configuration below. You can select in EAP settings whether you want to ensure the identities of an access point or Radius server. If it's checked, select Next a certificate to be used for verification. A Radius server is required to present its valid certificate that matches a certificate issued by a public certification authority. A common error in managing enterprise networks is failing to require mutual authentication. Another problem is accepting all the certificates pre-installed in a Windows system. This means that to run an attack, a potential intruder will only need to buy a valid certificate, which costs about $100. You should only trust certificates that were issued by your certification authority. You also need to have your own public key infrastructure.